Hello and welcome. My name is Neffin, and this is going to be a video series going over the sequencer module created by WASP. This will be a beginner-friendly series designed to help you understand the sequencer API step by step. We'll cover over most of the features and options to make it easier for you to learn how everything works, or at least to help you find exactly the information you're looking for. For the methods, I'm going to be separating them into sections, just so that everything can be properly time-stamped and organized. I've also included the official sequencer documentation in the description below, so feel free to pause the video and open that page up so that you can follow along and read the explanations that come with it. Now, without further delay, let's go ahead and dive in. We'll begin with the effect section of the API, since that's where most new users like to start, getting cool visuals on the screen right away. We'll go ahead and start with the required code to create a basic effect using sequencer. We'll build it piece by piece so you can see how everything fits together. So to start off with, we'll go ahead and create a new constructor called new sequence. We'll make sure that we set it to script. We'll then go ahead and tab over. Tabbing is not required, but is good for organizing your code so you don't get it lost within when you get to making bigger codes. It doesn't get lost in the minutia. So we'll do dot effect. We're going to start our first effect. We'll go ahead and put dot file, and we'll find a file name for this one. Let's go ahead and just choose Bark Inspiration. We'll then set a location, and we'll go ahead and make it token. Don't worry, I'll explain all of this once I've built it. Now we'll close it off with .play, and these are the required things to make sure that you can play a sequence at all times. You all constantly be using these to play any and all sequences. Alright, so new sequencer is a constructor. We're opening the constructor. .play is where you close your constructor. You're saying, hey, I'm finished with this one, and I want you to play this series of effects or animations, whatever you put underneath it. Dot effect is the API, and we're setting what effect we want to play. Now we're defining the effect, putting as dot file. We're putting the animation. This one's using the JB2A Bardic Inspiration. And then we're setting the location, which is token. Token is predefined in Foundry as the selected token that you are clicked on. It'll automatically play when you execute the macro. Okay, so we'll go ahead and go further into the at location, because token is one of many locations it can be used at. So let's go ahead and close this out. We'll go ahead and open up this one here. So I have a bunch of different targets, per se, for it. Its at location has been changed depending on what I wanted to target. So let's say I wanted to target token instead of the selected one. I'll go ahead and target the token and execute the code. This is the code that matters for that. So we'll have constant target equals array from game.user.targets, and we're targeting the first target in that array, meaning if I target a second target for any reason, it won't play on that second target, not unless I deselect the first target. Now, you can change this by changing the number from 0 to 1 to 2 to 3, basically going up on how many creatures you have targeted. So if I target 1, 2, 3 targets, and I want to play it on that second target, I would go ahead and put it as 1 and execute the code. So that will execute at the second target. You can have multiples of these. Just make sure that you rename the constant to something else for each iteration that you have. Next, we'll go ahead and go over coordinates. So I want to play at a certain coordinate on the map. The coordinates start from the top left corner over here, and every square is 100 pixels by default. So I have this set to 400 by 400. So I go 100 by 100, 200 by 200, 300 by 300, 400 by 400. It'll play right here. So if I execute the code, it'll play in that location as it should. You can move the X and Y. They don't have to be the same. Just wherever you want in the mapped canvas. Wherever you want in the canvas for them to play is where this will go. All right. Let's say that you want to have it play at the latest template you put down. I have 3 templates here, 1, 2, and 3. I have placed them in order. So the first one, second one, third one. I want it to play at that third location, the most recent one I placed. So we'll go ahead and set it to latest template, the constant I've set for it, and execute the code. It'll play at its latest template. This is good for item macros that have the ability to place a template first, and then it'll automatically find that template you just placed and play that macro at that location. Play the animation at that location. Next, we have just template. Template is set to basically how they've been placed in order. So I've, as I said, placed 1, 2, and 3. Let's say I want to put it on the second template. I would change the 0 to a 1. It'll now execute on the second template I've placed. I want to play it either on the first one. I'll just put it back to 0 again. And you can keep going and going forever and ever for how many templates you placed. Next, we'll have tagged object. This takes a module called tagger. This will be a tile like such. This is meant to target tiles. So I put a tag on this one called tag on tile. I already have the tagged object set up, doing wait tagger get by tag tag on tile. This right here is what it's trying to find. You can put any name you want here. It doesn't have to be tagged object. It could be rock or whatnot. But for this case, we're going to go ahead and use tagged object. And right now, the 20-sided die here has it tagged. So if I execute the code, it's going to play it at that location. Okay. So I've gone over what basically is required for you and things that you'll actually need to play your macros at locations that you want to play them at. Now I'll be going over .attach to, which can replace at location. At location plays a animation at the location of when the animation is initially played. Attach to instead attaches the animation to the target, so that if the target does move, the animation moves with it. We can go into the options of attach to and change them up so that they play a little different. So for now, just the basic attach to with its options set at their default value. We'll just attach to the token when played, so that if you move the token, it moves with it. So well, so dot attach to token is all that you need for that. If you want to add on options, you'll put them in curly Q brackets, and do each option with a comma after them to put additional options. So we'll go ahead and start with bind visibility. Bind visibility as an option binds the visibility of the animation to the token. So if I execute the code right now and I go ahead and change its visibility, you see how it just goes opaque. It's because the animation will also be hidden when the token is hidden. If I set that to false, when I hide the token, the animation will still be visible. This is good for making your tokens invisible, but at the same time not having animations such as Guardians of Faith, or was it Guardian Angels? Basically, the Guardian spell not disappear on you, so that you as other players can still see it, or have an enemy still have the Guardian showing as well to the players, so that they can see the range that you'll get hit at, because those things don't go invisible just because the player does, the NPC or the player does. All right, then we have bind alpha. What bind alpha does is it's bound to the opacity of the token. So bringing up the tokens menu, we'll go to the opacity of the token. So if I decrease the opacity here and update token, you'll see that the opacity of the animation gets more clear as well. It does look like the hidden, but it's actually just see-through, so the players will still see it. All right. Then we have bind elevation. Bind elevation means that no matter what the token's elevation is at, the animation will stay at that. Go with the token's elevation. So if I set it to false, though, what will happen is whenever you play the macro, whatever the current elevation is at, by default, it will play. It will play at that elevation, and then if you increase the token's elevation, the animation will stay at that elevation, meaning the token will go above the animation. If you set your dot elevation to a number, it will automatically look at that if the bind elevation is false instead of going with the default. But we'll be going over dot elevation later. Then we have bind rotation. Bind rotation, what that does is if the token rotates, so does the animation. It'll stay locked with its rotation. If you have that turned off, it doesn't matter how much you rotate the token, the animation will stay at its current rotation, whatever you have it set to. Then we have offset. Offset doesn't have a true value, true boolean. Instead, it has a X and a Y value. So when you're putting that in, we'll go ahead and close that off and do curly Q brackets. X is 100 and Y is 100. You can set the values to anything you like, but when you play this again, which we'll go ahead and do real fast, end effect, execute macro, you'll see that it is off by 100 and 100 pixels down and to the right. Let me go ahead and erase that and uncomment. So you can basically offset the animation as you need to. Some animations come with a bit of offset already. When you're dealing with certain animations, they might not be in the right spot for you to start off with, or just not centered enough for you. You can go ahead and use that offset to center them. Now, random offset is a little different. It has a true and a false value. So if I set this to true and I play the animation, it's going to play it at a slightly offset value. I think it's from 25, I think it's 25 pixels from the token, roughly. But you'll see that as I play multiple animations, they're all slightly off. I'll go ahead and set that back to false. Lastly, we'll go over grid units. Grid units is used in tandem with the offset value. Instead of using 100 by 100 pixels, you can instead use 1 by 1 grid. So you'll do x1 and y1 to make it do the same thing that we did with the offset earlier. This isn't necessary as long as you know the pixels, but if you like grid units better, it's a good way to do things. Especially if you're constantly having your grid units change from map to map. I have mine consistently at 100, but some people like to change them up to 70 or whatnot, so grid units makes that uniform across all types of animations. So it'll move a certain amount of squares instead of moving a certain amount of pixels. All right, so that is attached to that can replace .atLocation. All right, so now we're going to go over stretch 2. So bringing up stretch 2. So right now I have a constant set of target, and I've set it to this token here. We will go ahead and play an effect of an arrow. This arrow is a stretched animation. When you play it on a token normally, it will play this area as the center, and we'll basically play that on the left of the token and then on the right of the token. So we want to go ahead and have this play at the beginning of this token and then shoot off to another one. So we have this attached to a token. You could use @location as well, but I'm using attached to token because of an option that the stretch to has. We then put stretch to target, and you could normally just close this off with another parentheses. So, and then get rid of all the options, and it'll work just fine. But if you want to add options, as usual, add the options with commas in between the curly Q brackets. Currently, as it is, if I execute this code, it's going to stretch to that target at its current location. So if I decide to move this token for any reason, you'll see that the animation does not keep hitting the target. Instead, moves. It keeps its current length that it's playing at. Now, that's because of attached to is set to false by default. If I give this .stretch to attached to true instead, what it's going to do is it's going to link the two tokens together like a tether. So no matter where this token moves, the animation is going to play from point A to point B, and the further the animation is away, depending on the animation, it can get bigger. For JB2A, he's done a really good job, and remains relatively the same size. You barely notice any size changes. Okay, so this is what I consider the required API for Sequencer. These are the basic tools that you're going to use a lot of the time. All right, from this point, we will begin going over the timing methods. The timing methods are methods that control how the animation plays from the beginning of its animation to the end of its animation. How often it repeats, or if it plays in the middle of its animation, or it stops early, or it continues forever until ended. So we'll go ahead and go through each one individually. For those that are not familiar with commented code, when I put these double slashes in front of a code, it turns it off. Right now, as we have it, it's just a normal sequence. It's playing at the location of this token, and we'll go ahead and play the aura theme. What we're going to be doing is we're going to be messing with its timing. So normally, I'm going to go ahead and show you how we get the timing of this thing. We'll go into here and play the blue one. So you'll see right here, it says the duration is 8,700 milliseconds. So 8.7 seconds. That's how long this animation is. So normally that's what the animation will play at. It'll play for 8.7 seconds, unless you want to change that for any reason. So let's say that I don't want it to be 8.7 seconds. I want it to be 12 seconds instead. I'll go ahead and put it as 12,000 milliseconds. So we'll execute the code. It'll go ahead and play its beginning animation, its middle animation for till it's ready to end, and then play the end of it, and then continue the loop until it eventually ends. Because I would put it at 12,000 and the animation is 8,700, it only plays through a portion of the second animation. If I put this at 17,400, it will play the animation twice. You can have the duration super short to not play through the whole animation, or super long, depending on just what you need for your animation. Now we'll go ahead and do .persist. .persist is fairly simple. It's you execute the code with .persist on. The animation will continue to play its entire animation the whole way through. So there are exceptions to this rule. JBTUA has been very tricky with that one. So like with this one here, what will happen is this animation has a beginning, a middle, and an end. If you have a persist on a aura like this, it will play the beginning animation and keep the middle animation going on the .persist until you decide to end it. So if I go ahead and end the effect now, it's going to play the ending animation. So it'll play that for a little bit, go through its last loop, and ending animation. Normally, what it will do is it'll just repeat the animation over and over and over again. So then we have .delay. .delay, it's pretty straightforward. It delays it by so many seconds. So I have it set for 5 seconds. So if I execute this code now, 1, 2, 3, 4, 5, and it plays. Basically, it's just to delay the timing of an animation to match it with others. Now we have start time. What this tells the animation to do is I want to only play a certain part of the animation. So I want to start at 2,000 milliseconds into the animation. So only play 6,700 seconds all the way to the ending. So if I execute the code, it plays it after the intro animation and then goes all the way to the end. You can do the same thing with start time percentage. This will do 25% of the total milliseconds and play that animation. For this case, it's roughly the same as the 2000. The same thing works for end time and end percentage. Instead, it plays the beginning of the animation and you decide to end it early. So we ended it early, so it only plays 6,700 seconds of the entire animation from beginning to close to the end, and 2,000 seconds before it finishes, it just cuts it off. If you want to play a certain time range of the animation, you'll need to define it. So .time range does that. What you can do is say, okay, well, I want the starting time to be 2,000, and I want the end time to be 4,000. So when I execute the code, it'll play 2 seconds of the code, because that's the difference between the 2000 and 4000, and cause you to only play that section of the animation. And you can have this persisted so it keeps repeating that animation over and over again for that section. And then we have extra end duration. So if I go ahead and do this, say for 2000 seconds, what it's going to do is it's going to go ahead and play the animation for the 8.7 seconds and then add an additional 2 seconds to the end before it actually plays that ending animation. So instead of 8.7, it's playing for 10.7 seconds. Lastly is the wait until finished time method. This one is for putting extra effects on. So I'm going to go ahead and put a second effect on this one. We're going to go ahead and copy this and put a second effect. We're going to go ahead and change the effects to something different. So clear this out. Let's go with Arms of Adar. So wait until finished will cause this animation to play, and it will wait until this one is finished to play the next animation. So execute code. If you have it spelled correctly. I had it, I forgot an I. Okay. So now it's playing the full animation. It's going to wait until it's entirely finished, and then we'll play the Arms of Adars right after. Now, wait until finished has you can put numbers within this. So you can have it delay by, let's say, 5 seconds. And what will happen is it will play its entire animation here. It will then decide, okay, well, hey, wait 5 seconds after this ends, and then we'll go ahead and play the Arms of Adar. So 5 seconds later, Arms of Adar. So you can also do this in a negative, though. So the animation that we had before is 8.7 seconds. We want to play this halfway through that animation. So we'll go ahead and do 4,350. So if I execute this macro now, halfway through that this animation, Arms of Adar is going to pop up. So that's how basically wait until finish works. It's a delay with restrictions to wait until an animation is finished. Basically adds on the duration of the animation on top of the wait until finish, or takes it away from the duration if you put it negative. All right. So that's the timing methods. All right. So now we're going to go over the effect manipulation methods. This is going to be subdivided into further sections, which is size, transition, rotation, color, and flips. We'll start with the size section. This is going to manipulate the size of the animation. The size of the animation already has a preset, already set by JP2A's module. And so Sequencer overrides that in different ways. We're going to start with dot size. We're going to go ahead and put width and height within curly Q brackets within the parentheses of size, and set its width and its height to 400 each. This is in pixels. So when I activate this, it's going to be 400 by 400 pixels. If I want to make it 1400 wide instead, I can do so. This is the best. I'm sorry, I wouldn't say the best. This is you have the most control over the animation with dot size, considering its scale. So then we'll go into the simpler ones, which is dot scale. Basically, 1 is the default, so it'll play at its normal size. You can go ahead and decrease it down to 0.1. Plays very small, all the way to 10. You can go further than that, but as you see, it goes off the screen. So up to you how big or small you want it. Next is scale to object. This takes the object into consideration when playing it. Our object is currently the token. So when I say scale to object 1, what it's going to do is it's going to play within the token's boundaries. If I decide, well, I want it to be bigger than that, I can put 4. The reason why you'd use dot scale to object is if you're going to be playing on multiple different sized templates or tokens to have it increase in size or decrease in size depending on the token's ratio. Okay. So then we have sprite scale. So when I go ahead and play sprite scale, it's just scaling the sprite itself. This works relatively the same as scale. It's just taking the sprite's original size into consideration. I'm not sure the difference between sprite scale and scale, but you can do either or, and it won't cause any issues. So now this is just the sizes. At this point, we'll go over now transitions. Transitions are fade in, fade out, rotate in, rotate out, scale in, scale out. These are used at the beginning and the end of an animation. So when it says in, it means it's scaling while the animation's coming into play. When it says out, it means it's being played when the animation is going it's finishing up the animation. So when I do fade in, let's say 4,000, because the animation's 8,700. It will slowly do this opacity fade in up until the 4,000 second, and then we'll play normally. Versus if I do dot fade out and I do the 4,000, what we'll do is we'll play normally at the very beginning, but then fade out slowly as the animation comes to an end. This makes great for transitioning into other animations, as it makes it look smoother instead of like a jarring jump. Okay, so let's say that we want to have it rotate in for about 2,000 seconds. We then want it to rotate for 180 degrees. We will set 180 as the degrees, 2,000 as the duration as the second number, and then we'll go ahead and execute the macro. So it will now spin as it comes in. The same thing with rotate out. If we do the same thing, so 180, and we make it 2,000 seconds, when the animation finishes up, it will decide to rotate out. You can, to rotate it clockwise, you'll do positive numbers. To rotate it counterclockwise, you'll do negative numbers. So if you wanted to rotate backwards, you'll do a negative 180, and it will play on out, and then we'll end up rotating counterclockwise. Alright. So, then we have scale in. Scale in requires a few things as well. This one is the size. So it's comparative to the original scale of the token. So let's say it's a scale of 1 right now. So I want to have it scale in from 0.5. So at the very beginning of it, it will scale in from 0.5 to 1. So when I execute the code, oh wait, forgot the duration. So we'll say 2,000 seconds, 2,000 milliseconds. But you saw that it started off smaller than the object and increased to 1. Let me go ahead and make that smaller to make it more visible. So it starts from the very center of the token and then expands outward. The same thing will happen if you create it bigger. So let's say I make a scale into 10. It'll scale down to 1 within the 2,000 millisecond duration. And Then we have scale out, which does identically the same thing. So if I do 0.5 and I do 2000 seconds, what will happen is the animation will come in as normal. And when it starts to finish up, it will go ahead and move in closer to the token and then disappear. Okay. That's transition for you. Basically, this is a good way to transition between animations and makes it look smoother and gives it more flair. Okay, now we'll go into rotations. Rotations are pretty simple. We're going to go ahead and skip rotate towards. We'll go ahead and come back to it in just a moment. We're going to go ahead and do rotate first. Rotate, what it literally does is it takes the normal orientation of the macro and rotates it just 90 degrees to the right. Not a good animation to show this with. Let's get a new one. So we'll go ahead and do... Arcane Hand will be wonderful. So I'm going to go ahead and comment that out. We'll do dot file hand. So when I activate this again, you'll see that now it's rotated 90 degrees to the right. And if I subtract it, it's 90 degrees to the left. Alright, then we'll go ahead and do a random rotation. Random rotation, we'll just choose a random rotation from 1 to 360. Then we have zero sprite rotation. It literally says what it does. It basically causes the animation to not rotate at all. Ooh, I misspelled it. Sprite. It would help if I spelled that right. But basically the animation will not rotate at all for any reason, even if the animation, even the token underneath it rotates. Alright, then we'll go back to rotate towards. So rotate towards requires a secondary object. So we'll go ahead and add a secondary object real fast. So let me go ahead and do drawings. We're going to go ahead and choose targets. Get the text from here. So now we go ahead and rotate towards target. And so now when I play the animation, we're going to go ahead and target this token as an example. Execute. The animation will move towards that target. So rotate towards the target. So when you're doing weapons and whatnot, it will always point the weapon towards the target, as long as the animation is done correctly. If it turns out the weapon is backwards for any reason, what you can actually do is fix it by doing .rotate as well and doing a 180. So what will happen is it will flip on you. You can use those in tandem to cause the weapon to reorientate itself. So that's basically rotation. Play with those. They will animate different animations, react differently, so you have to just figure it out by feel. Then we have color. I'm gonna go ahead and change it back to the other file because it's gonna be easier to show color with that. So we want to tint this. We want to tint. It's originally blue, so let's say we want a hex code for green. Perfect, that will do. So we'll go ahead and put a hex code for green in there, and execute the code. It will tint the color. It won't change the color. So this is originally blue. It's much easier to change to like tint with the colors, but sometimes you'll get a different color by tinting it or a different hue. Let's see which one doesn't go real good with green, blue. Let's say red. So if I wanted to tint it red, I think that it would turn out purple. Nope, it's apparently very. This one's very good about tinting correctly. Tint will be very useful to just recolor things. Filter actually has multiple options. These options include color matrix, glow, and blur. Let's go ahead and start with color matrix. So what you'll do is you'll just put in quotations, color matrix. It does relatively the same thing as tint, except it attempts to change the color of the item entirely. So we'll put in curly Q brackets hue. We want to go ahead and change the hue to, let's say 330. It works from 1 to 360. It's a color wheel. So you notice it changed it to more of a teal color. Let's say I want to make it, let's go 20 on the opposite side. It makes it more of a light purple. And then we'll go for something in the middle, so let's go 180. Makes it more of a tannish gold color. But basically it mixes with the blue coloring. It has a stronger mix than tint, so it can help change the color a bit more. Then let's go into glow. This is one of my favorites. And we'll go ahead and do just the glow that is suggested on the site, which is a nice strong red. You'll use hex code again. Hex code can be put in two different ways. So if I wanted to do, let's go back to .tint real fast. Instead of the hash chat tag, you just do 0x and get rid of the quotations. And I'm going to go ahead and turn off the filter and execute the code. It will do the same thing as the hex code. The hex code can be written in two different ways. You can do the same thing with here. If you want to, you can put the hex code in quotations and do the pound key. Otherwise, just put 0x and then the six letter number combination to get your color. So with the glow filter, this highlights the transparent areas around the token. So, around the animation. So, as you see, it's highlighting just the edges of the animation itself. You can do this on tokens, animation tiles, whatever has like a transparent area on it, and it will like highlight around the non-transparent areas to make it pop. Yet again, controlled by hex code, so you can just change the hex code to any number, letter, or combination you want, and it'll change its color for you. Then we have blur. So we're going to go ahead and just copy the standard blur that's on there. And execute. So as you see, it's made the animation not as clear. Basically, it's blurring the X and the Y values of it. So let's say that I don't want to blur the X, but I want to blur the Y. Ow, that hurts. Or I just want to just have no blur at all. You can slightly control it going backwards and forwards. Just to get to the right amount of blur that you want. This, I haven't found much use for it, for blur, besides just like doing like the blur spell or mirror image, but it's not a common one I use very much. Okay. So that's just going over colors as well as the filter options that deal with the colors. Okay, then we'll go into flips. Flips are, wrong one. Flips are flipping between the X and the Y values. So when I say mirror X and I play the animation, I'm going to go ahead and do it with the hand again because it's better. So what's going to happen is normally the hand plays in this rotation with the thumb on the right side. it's now going to go ahead and flip the X value and play the thumb on the left side. We can then do the same thing with the Y. Having the fingers normally go up in orientation, you can flip it and have them go down. You can do the same thing with the dot rotate, but this just makes it easier, like mirror Y, mirror X, you'll get on the other side. It's also a good way to flip the orientation of the animation so that if you need like a left hand and a right hand, that X and that Y value will help get that for you. Then we have the randomized mirror X and the randomized mirror Y. I'm just going to play the mirror X, this one. Basically, what it does is it just chooses between 180 and 0 and flips it one way or the other. It's a 50-50 chance that will happen either way. This is a good way to cause variation in your animation so that it looks a bit more chaotic. Alright, so this is the end of the effect manipulation methods. We're now going to go ahead and move to screen space methods instead. So screen space methods, as they say, are played on the screen. So instead of at location, you'll use screen space to play on the screen above the canvas. So when I execute the code, it plays the animation in the center of the screen as a default, as well as at its normal size. So if I decide I want to do animations on the screen for everyone to see, it'll play relative to the size of the player's screen. If you don't set up a screen space scale to match up with their screen size. So with we'll then add on screen space above UI. What this does is it plays it above any of the UI that's blocking it, so that, let's say they have a character sheet up or whatnot, that would block the view of the animation. You don't want that to happen. You want it to play above so they can actually see it. This is good for like spooky, ominous animations or alerts, such as ambush or whatnot, popping up on the screen suddenly in text. We can also control where it's placed by doing a X and a Y value with the screen position. So if I do X 100, it's going to play it 100 pixels to the right. Versus if I do negative, let's say 400 as a more extreme one, you'll play it 400 to the left. I think that the max distance is 950. Yes, the max distance on each side is 950 for X. So if I put that back to 0, and then we go for this, I believe it's 500 on the Y. Yes, so it's 500 on the Y on both negative and positive values. Is the distance of the screen. Then we have screen anchor. Basically what the screen anchor does is it's the same thing as space position, except it's done in grid units. So the entire right side of the screen is one grid, and the left side is another one grid. So if I put this at 0.5, this is going to anchor the animation down in the center. So you can put this at 0, and it will go all the way to the left here, and all the way to the right if you put it at 1, as you can see. Basically, this entire canvas is just one grid unit, and you can control that entirely here. So 0, 0 will play in this top left corner of your screen. Um, this is for like you can do like point. You can actually do really pinpoint accuracy with this. It's basically it's entirely the same as screen space position. So if I do 0.123, it's going to play at pixel 123. You can do very precise stuff so that it can play correctly. I'm going to go ahead and set this back at 0.5 and turn this off. Then we have screen space scale. 1 is not a valid number. We can go ahead and copy the 1 from the wiki, and we'll go ahead and make this simpler to read. Oop. All right. So effectively what it's done is there's an X and a Y value for the scale. So when I execute the code, it plays normally. If I want to change the X of it, we'll go ahead and make that 5. It will do the same thing that dot size does, basically expanding its width and its height. Y being its height, X being its width. It also has other options, such as fit X and fit Y. What this does is when you set this to true, it will it'll take the resolution of the screen of the player, of the client, and execute the code as if it would fit the entire screen. So at a scale of 1, this would fit the entire screen that big. Let's say I make this 2. This would be the full fit. And it would change depending on what the resolution of your player screens are. Okay. Then ratio X and Y. It can have to be set. One of them has to be set true. The other one false. They can never both be true. So I'm gonna go ahead and set these both to false real fast. If I can spell. And then so ratio X, what that does is when you set it to true, it takes the size of the animation and sticks it at that size, so that no matter what the ratio of the screen is, it will always play the X of that animation at that size. It will only change the Y value. The same will happen if you set ratio Y to true instead. What will happen is the animation will always play as if Y is 1, but will play X as the size of the client's screen. So that goes over the basics of screen space methods. We'll go ahead and move on to layer methods now. Okay, so layer methods. Okay, so layer methods are pretty straightforward for the most part. We'll start with dot elevation. Elevation is pretty simple. Currently it's set to 20, so it will play the animation at a elevation of 20. Right now the token is at 0. Let's say that I bring out a tile. Let's go with just a rock and set its elevation to 30. So now when I select the token, it will play the elevation below the rock. But if I increase it above the rock itself, it will play above it. Okay, so that's basically just elevation. It's pretty straightforward. It just plays at a certain elevation for the token, for the animation. Then we have z-index. Z-index is used in tandem with other animations. What z-index does by itself, by a single animation, it doesn't do anything. but it layers the animations on top of each other. So if I have one set to 1, and let's go ahead and just make a second dot effect real fast. So we'll go ahead and do dot effect and fix that in just a moment. Dot file. And we'll go ahead and do a Z index effect. We'll get a different animation. Let's go ahead and do byte. That's a good one. So I want this byte to play below the animation. So I'll put it as 0.9. So when I play this animation in just a moment, because first I have to set an at location for this token. Now when I play that animation, you'll see that the animation is below the token, below the first animation that's set up for Z index 1. But if I want this one to be lower, let's say I put it at 0.5, when I play it, you'll notice that it is above the animation. That's not as clear as I would hope it'd be. Let me go ahead and increase byte size. We'll do dot scale. Dot scale. Let's make that 3. So you can see that the byte is above the animation now. We'll go ahead and show the below again. So if I put this back at 1, you'll see the byte is below the animation. So Z-index controls where the animation is played relative to other effects. So if you don't want one effect stacking over another, this is a good way to organize them. Then we have above interface. So above interface basically says what it does. It plays above the interface of the canvas. So if there is lighting effects or whatnot, this will play above that, and will basically be able to be seen by everybody. If it's above walls, above... basically just above walls and lights. Let's say that you just want it above just the lighting. Well, you can do above lighting so that the lighting doesn't affect the animation in any way, form, or fashion. When you play lights, the lights can slightly colorize the animation itself as if it was in the environment, which is good, but sometimes you just want it to be that exact color and pop. So that's a good way of getting it above the lighting. Most common one it used is below tokens. Basically what it does is it puts it below the token, and so that it's not interfering with the stuff above. So sometimes you don't want an animation to play above, either because it blocks the view of something, or it looks better because it's supposed to be underneath it as if it was Guardian of Faith, like a floor effect or an aura. Then we have below tiles. So this will play below tiles such as like objects that are on, or like furniture that you've put in your map. So for that intents purpose, let's go ahead and pull out a tile real fast. I'll go ahead and pull this one out, and I'll execute the code. If I click the token, of course, and you see that it is behind the tile. Lastly, going over the last one layer, is sort by layer. This will cause the animation to play within a certain layer. This can be used with tandem with Z-index to organize things. So if you want some animations in the weather layer, but you want you have multiple animations in the weather layer, you can do Z-index as well to stack them the way that you want them to stack. So it's like clouds, rain, and hail. Having all three of those at the same time, you can have them stacked in different at the weather the weather layer, um, and then also give it a z index so they don't play over each other. So that's basically layer methods. So now we'll be going over sprite positioning. So sprite positioning is basically causing the sprite to move to a location or start at a different location than it would normally. So I'm going to go ahead and comment these out real fast. Okay, so we'll go ahead and start with move towards. So move towards requires another object for it to move towards. So we're going to go ahead and pull out this one again. We're going to go ahead and target. So I wanted to move towards a target when I play this. We'll go ahead and select the wizard and target the sorcerer. So when I execute the code, what did I mess up? Oh, I forgot the allocation. Okay, 1 second. Dot at location. Input token. Alright. So when I execute the code now, you'll see that the animation moves from one location to the other. So this is used in tandem with move speed. So move speed is at standard default of 1, I think. Nope. 1 is super slow. Basically, 0.01 is like we're talking super slow, and 20 is very fast. I'm gonna go ahead and end that effect. So we'll go ahead and set this to let's say 5. You see how it's slowly creeping across the field. It'll keep repeating and repeating until it's finally reached its target location. Versus if I set it to 20, it's going to go a little bit faster and try to zip across the field. The animation I tested earlier was a lot faster, apparently. So let's go ahead and speed this one up by 100 instead. So let's end this one. And if I do 100, basically you can control the speed of this animation as you will with the dot move speed. But move towards target will always point towards the target. So if I click it from that direction or from this one, it will always go towards that target or object that you've selected. Until it reaches that location, it will keep repeating the animation over and over again. Alright. Then we'll do rotate towards. So with rotate towards, we've already gone over that one. But basically, rotate towards the same thing. It rotates the token towards that object, and plays it towards that location. Then we have sprite offset. Sprite offset basically causes the animation to play at a location that is normally not. So let's say that the location is 0, 0. I want it to play offset about 100 pixels. So that's to my right, 1 square. It will now center in on that 1 square and offset the sprite's animation. The sprite is still technically right where I left it. It's just that the animation has been moved over. I'll remove that. Now we'll go to random sprite rotation. This one basically rotates the sprite randomly, slightly. Let me go ahead and pull out the hand again, as this animation will not show real well otherwise. So, dot file, hand and comment out that code. So when I play random rotation, it randomly rotates the sprite. You can also do sprite rotate and set a certain degree to rotate it. What did I do wrong? Oops. Sprite rotation is what I meant. Sprite rotation will just rotate the sprite, just like rotate does. Rotate rotates the sprite and the animation itself. Basically, that's the more advanced stuff. Don't need to worry about that right now. But basically, sprite rotation and rotate do the same thing for the most part. You'll learn more about sprite rotation versus rotation later. Rotate. So we've already gone over rotate, rotate in, rotate out. So we don't need to worry about that. We'll go ahead and do snap to grid instead. So snap to grid is really nice when you're having things move across the field. What it does effectively is, let's say that you move an animation from one point to another, but you want it to land on the center of a square. This will cause it to snap to the grid. And not go off center for any reason. So let's say that you set it to play at a token that is slightly off center. It would cause it to snap to grid here or here, depending on how far the token is on the left or the right. And then dot center does basically the same thing. It centers it on the token, making it go to a certain position of the token when you play it. Then we have anchor and sprite anchor. What those effectively do, anchors the sprite container down to a certain location. The sprite can still move, but the sprite container can't. And then sprite anchor does the same thing, where it anchors down the sprite, but the sprite container can move. What these are used exactly for, I'm not sure myself. This is more advanced stuff than I've reached. I haven't found a real good use for them yet. So I wouldn't suggest messing with them until you understand sequencer a bit more. Okay, so lastly, I'll go over audio methods. So audio methods, I don't really have a good example for them, but effectively what they do within .effect, if your effect for any reason has a sound, you can put .volume within the effect and set a volume from 0.1 to 1. And it will play at a certain volume from the animation itself. Audio, fade in audio and fade out audio do the same thing as fade in and fade out, where fade in at the very beginning of the audio will cause the sound to slowly fade into existence, and then fade out audio does the exact opposite, where at the end of the sound effect, it will slowly fade out the sound until it doesn't exist. So these are the methods that I can explain to you as a beginner that you would use most often. I hope these instructions help you. I do apologize about not having more visuals. But I believe I've explained most of the methods in a way that you can easily digest or understand. And hopefully this will assist you in understanding them. Otherwise, if for any reason you don't understand anything that I've explained, please comment below. I will do a touch-up video on anything. I'll expand on any of the methods that need further explaining. But I believe I hit all the key points for you. So thank you for watching. Please leave a like or a dislike. I like the feedback. And any comments you wish to leave. I am more than happy to explain anything that I've gone over. If you put it in the comments, I will definitely answer your questions. Alright, well, thank you for watching. I will see you guys later. Bye-bye.